In today's video, we are going to understand the concept of time division multiplexing. Before time division multiplexing, let us understand what is multiplexing. Multiplexing means simultaneous transmission of multiple signals. That means if you want to transmit more than one signal through a common channel, then we will use the process of multiplexing. The multiplexing process is of three types. First is known as frequency division multiplexing, in which the multiplexing is on the basis of division of frequencies. Second method is known as time division multiplexing, which is our today's topic. And third is wavelength division multiplexing, which uses optical fiber for the transmission of lights. So today's topic is time division multiplexing, in which the division of the transmission is on the basis of time. That means we will allot a different time slot to all the transmitters. Suppose there are 4 transmitters, and let us understand the cycle of 60 seconds. So every transmitter will be allotted 15 seconds each. So 1 to 15 seconds is allotted for transmitter 1. During that time, transmitter 1 can transmit the data, as many data as it wants. Then after 15th second, 16 to 30th second will be allotted to transmitter 2, and so on. So this way division of time is there, and that way the data is transmitted in time division multiplexing. Basically, time division multiplexing is of two types. One is known as synchronous time division multiplexing, another is known as asynchronous time division multiplexing. So first we will understand the concept of synchronous TDM, that is synchronous time division multiplexing. So in synchronous TDM, to understand the concept, I have taken a multiplexer at the transmitting end and a demultiplexer at the receiving end. At the multiplexer, we have attached 3 transmitters which are transmitting the data A, B and C respectively. And accordingly, these transmitter will be having the respective receiver at the receiving end, receiver R1, R2 and R3, which are receiving the data A, B and C respectively. So now what is the process? This is the channel through which our signal is transmitted. This data is transmitted in the form of frames. As you can see, these are various frames. So there are number of frames which is transmitted for the data as a data carrier, you can say, and every frame is divided in a specific number of slots. So these number of slots are always, as you can see, number of slot is equal to number of transmitters. So if the number of transmitters are 3, I am keeping the slots as 3 in every frame. So you can check that every frame contains 3 slots. There is a specific reason for keeping the slot same as number of transmitters. So what happens when the cycle starts? Suppose from 1 to 20 second, now we have divided the cycle into 20 seconds, suppose, because we have 3 transmitters. To 1 to 20 second, transmitter 1 will transmit the data. So its data will be allotted in the first slot. Then from 21 to 40 second, transmitter 2 needs to transmit, but during that time transmitter 2 doesn't have any data to transmit, so this slot will remain empty. Then it will move to the third transmitter, which will transmit the data in their allotted time. Then again it will move to transmitter 1. Now the next frame will come. In the next frame, suppose A is transmitted, B is transmitted, and suppose at that time C doesn't have any data to transmit, so this process will be continued. Let us say in this only B has transmitted the data, A and C doesn't have any data at that particular instance of time when they need to transmit the data. So such frames will be received by the receivers. Receiver knows that every frame's first slot is for me. So receiver 1 will receive the data from first slot of every frame. Similarly, receiver 2 will receive the data from the second slot of every frame, and so on. So this process is easy to understand, and I hope you understand the concept of transmission and reception of data with the help of this frame and various slots. Now, what is the problem in this process? As you can see, there are various empty slots. So that means we are not utilizing the bandwidth of transmission fully, or maximum utilization of bandwidth is not there in particular process. So to overcome that problem, we have moved to asynchronous transmission. So asynchronous TDM is somewhat different with this. Let us see how asynchronous TDM works. So to overcome the problem of synchronous TDM, we have modified this process which is known as asynchronous TDM. Now what is the modification? The modification is number of slots will always be less than number of transmitters. So as you can see, we have 5 transmitters and 5 receivers, but we have kept the number of slots in every frame as 3. Now this is not necessary that always keep the number of slot as 3. You can keep the number of slot 4, 2 depending on the efficiencies of the transmitter. Let us understand it by this. If you have suppose 10 transmitters, and out of those 10 transmitters, 7 transmitters are equally efficient and 3 transmitters are less efficient. So in that case, we will keep the number of slots as 7. Suppose if 6 transmitters are more efficient, then we will keep the slot as 6. And suppose all the 10 transmitters are equally efficient, then we will use the synchronous method, because in that number of transmitters are always equal to number of slots. So in this case, I have assumed that out of 5 transmitters, 3 transmitters are more efficient and 2 transmitters are less efficient. So I have kept every frame with 3 slots. So now what will happen? Suppose transmitter 1 will be having data during their transmitted allotted time. It will transmit the data. So A will come here. Then suppose B doesn't have any data. Then third transmitter has data. So C will come here. Then D doesn't have any data, E will come here. Then suppose A has transmitted, B has transmitted, then E has transmitted, then C, E, A. Just a random number I have written. That means at that particular instance of time, whichever transmitter has transmitted the data, that slot will be filled by, successive slots will be filled by all the transmitted data. So now, in the previous case, that is in the synchronous TDM, we have seen that receiver 1 knows that the first slot of every frame is their data, and receiver 2 always knows that the second slot is the data which is my data. But in this case, you can see that in any slot, any data is filled, because we need full utilization of the bandwidth. So we have filled all the data. So the problem of that empty slot is overcome in this method. But another problem you must have understood, that arises a new problem, which is now receiver, how will they understand that in which slot their data is there? So to overcome that problem, what we do is, whenever we fill any data in any particular slot, we add some address with that. Suppose A1, C3, E5, A1, B2, E5, C3, E5, A1. So this number or this address or this identification is known to all the receivers. So all the receiver now will check every slot of every frame. First frame arrives, receiver 1 will check all the slots, and in whichever slot it finds the address match, it will retrieve the data from that particular slot. This process will be followed by every receiver, and this way all the data will be retrieved and all the data will be received by all the receivers. So this is how your time division multiplexing works, both synchronous as well as asynchronous. So now, in continuation with the time division multiplexing, we will understand the concept of PCM TDM system. PCM we have already discussed in the previous video, which is pulse code modulation. Now if you have many number of pulse code modulated signal and you want to transmit those signals, so how you will transmit those PCM signal with the help of time division multiplexing system? So in this case, we have used 24 voice channels. Every voice channel is band limited to 3.4 kilohertz. So with the help of sampling frequency is greater than or equal to twice of the modulating frequency. So 3.4's double is 6.8, but we keep the sampling rate at 8 kilohertz. So these 24 voice channels will be transmitted Then this is a commutator switch which is connected to all the voice channels one by one, and these signals are then pulse code modulated and then transmitted with the help of repeaters, and then this PCM receiver will receive those signals and then they will be decommutated and received separately. So all the 24 received voice channels will be received separately by this. These low pass filters are basically used to remove any unwanted elements which are added to these voice channels or voice frequencies. To eliminate these unwanted signals, we have connected these low pass filters at the transmitting end as well as the receiving end. There are few repeaters you can see. So basically it depends on the distance between the PCM transmitter and receiver, because after every 6,000 feet the signal becomes weak as well as some distortion may also be introduced. So these repeaters will regenerate the signals after every 6,000 feet, as well as if the signal is having any unwanted signals or impurities, those will be removed by these repeaters. So these repeaters are connected after every 6,000 feet to reproduce the signal. This way PCM transmitter and receivers are connected through the coaxial cable with the help of some repeaters. So this is how your PCM TDM signal works. So this way you can understand the use of TDM system, that is time division multiplexing, in PCM system also. I hope you understand the concept of PCM TDM. If you have any doubt, please write it in the comment section.